I want to give you the opportunity to try a problem on your own. This problem here is another equation. You'll notice that we have a double angle expression here, and I'm not going to do this problem out because the only real difference between this problem and any of the solving we've done in the past is that we need to make a first substitution for this. And so I don't think there's a need for me to do the whole problem out when the only difference is that first step. So what I want you to think about is how you would change this so that this problem becomes manageable and solvable. And the key is what you would substitute in for cosine of 2x. So I'll let you think about that for a minute, and then I'm going to write down what the answer should be. So the best thing to do to solve this equation would be to use this identity in place of cosine of 2x. And now you can see that this problem is solvable. So I'm going to put dot 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 and let you try that on your own. Okay, notice here that the instructions say to determine all solutions. We've yet to use the half angle formula. So the half angle formula, in the half angle formula, that means, so let's just recall what those are. If you look back a few pages, you'll see that there's one for sine. So the sine of an angle cut in half, we can write that as plus or minus the square root of 1 minus cosine theta divided by 2, all under the square root. And so how do we use this? Well, this formula is useful only when we're looking at the sine of an angle divided in half. And so what we should think about is, first of all, we can't do we don't know the sine of 22.5 without a calculator. You know, it's not one of those special angles like 30, 45, or 60. But maybe we can write it as an angle cut in half, and then we can use this formula. So I think if you think for a few seconds, you'll see that it's the sine of 45 cut in half. And if you view 22.5 like that, now all of a sudden we're able to apply this formula. So I'll talk about the plus and the minus in 1 second, but this is going to be 1 minus the cosine of my theta now. So again, theta in this problem is our 45. All that divided by 2. Now what about the plus or the minus? Well, this is the sine of an angle, right? And this angle, 22.5, happens to be in quadrant 1, where sine is positive, so we should expect that the ratio should be positive. So I'm going to take the positive version of this angle. It's completely possible that I could have an angle here that would end up being in a different quadrant, like, you know, the third or the fourth. And in that case, if I were to apply the formula, I'd use the negative. But here we're in quadrant 1, where sine is, you know, sine of 22.5. It's got to be a positive. It's got to be a positive value. And now I just have to reduce this. That's really the main issue. So this is 1 minus 1 over the square root of 2 is the cosine of 45. All that divided by 2. This is all under the square root. And this is really just a cleaning up business now. So I'm subtracting. So 1 minus 1, this just kind of looks messy. We're going to clean it up a little bit. So 1 minus 1 over root 2, I can rewrite 1. If I use a common denominator, I can rewrite it as root 2 over root 2 minus 1 over root 2. And all that divided by 2. And so now I can write it as the square root of root 2 minus 1 over root 2. And divided by 2 is the same as times a half. And so now I've got root 2 minus 1 divided by 2 root 2. Okay, now there's a lot of roots going, kind of floating all over the place. It's kind of unavoidable. We could kind of keep going, but I would say this is sufficient as long as we are taking the square root of a simple fraction as opposed to a compound one, which is what this was. This is an acceptable answer for me. I'm going to leave this here. This is kind of almost like a review problem, and I want you to try this and see how it goes, and then we'll check in with me in class.